This is Unit 5, Chapter 1, Lesson 5. You are going to be graphing proportional relationships with Mr. Romanovich.
Hey, so today we are going to learn how to graph proportional relationships. We're actually going to learn how to graph relationships and then decide if they are proportional or not proportional. So by the end of this, you will graph ratios and rates to determine proportional versus non-proportional. And what you'll be able to tell us specifically is you'll be able to describe what and where the origin is. And you'll also be able to solve a problem like this. The cost of a movie is $12 for one ticket, $24 for two tickets, $36 for three tickets. Then you're able to use a graph to determine if that relationship is proportional or non-proportional. Let's start with the origin. So something that you're familiar with, but you might be a little rusty on. The origin is where our x-axis and our y-axis cross. As an ordered pair, it is 0, 0. So wherever the x-axis and where the x-axis and the y-axis meet, it is 0, 0. That's our origin. And then how do we determine proportionality when we do the graph? There's two things. One, the line that we draw has to be straight. The first criteria for proportional is that the line is straight. The second criteria is the line has to pass through the origin. It has to go through the origin. Otherwise, it is non-proportional. So here's example 1. If an animal moves at a speed of 6 feet per minute, determine if the animal's movement is proportional by graphing. So the first thing we'll do is what we did in lesson 5, and that is we'll make a table. And we've set up our table here with our two separate sets of data. We've got time and feet. So what we know is that the animal moves at 6 feet per minute. So in the first minute, it will travel 6 feet. In the second minute, it will travel 12 feet. Third minute, 18. Fourth minute, this is an 8. 24. Fifth minute, had to check my math, 30 feet. So now that we have our table, we're going to take these and turn them into ordered pairs so that we can then graph them. Here's our graph. And we set this up as time and distance. And what I remember was normally I would have the graph to look at, but for this it is hidden behind this piece of paper. So we're going to go, for each minute we're going to move 6 feet. So after we go 1 minute, we're at 6. 2 minutes, we're at 12. 3 minutes, 18. 4 minutes, 24. 5 minutes, we've gone 30. Now we're going to need a straight edge. Let me see if I can find my straight edge. Mrs. Benoit has it. Thank you. So now we're going to connect our points. And what we'll see here is that had I drawn this as accurate as possible, we end up with a straight line, and then it passes through the origin where 0, 0 is. So the question then becomes, is the movement of this animal, is that rate of 6 feet per minute, is that proportional? Yes, we can say it is proportional. Our line is straight, and our line passes through the origin at 0, 0, which means we have achieved proportionality. So it is proportional. Let's do another one. So the cost now. So this is an example 2. We're going to do the cost of renting a video game is in this table. So if we rent a game, it costs us $3. If we rent 2 games, it costs us $5. 3 games, $7. 4 games, it's $9. So the first thing we do is we make these into ordered pairs. So this would be 1 and 3. So that would be 1, 3, 2, 5, 3, 7, 4, 9. Now we're going to take those ordered pairs and bring them over here to graph. I'm going to hide them right here so I can kind of do this with the numbers. So if the number of games is 1, it's going to cost me $3. The number of games is $2. If it's 2 games, it costs me $5. Here's 2, here's 5. 3 games cost me $7. 3 games, $7. 4 games cost me $9. There's my 9. This kind of looks like my bad 8s, but it's a 9. I can confirm it with this. So 4 games cost me $9. Now, let's make our line happen here. And now we check for proportionality. So our first criteria, is the line straight? Is the line straight? And as we look at it, yes, the line is straight. Does the line go through the origin? It doesn't. It ends up hitting the y-axis somewhere around 1, between 1 and 2. So our answer to that is actually no. So since we didn't satisfy the criteria of it being straight and it passes through the origin, we know that this is non-proportional. Why doesn't it pass through? There may be a fee that we had to pay in order to rent the first game. So it might have cost us $1 fee, and then the first game was $2 more, and that's why it was 3. Just something to think about. So now let's see if we can do this. This is the magic of slides. One of them is going to come back. Push it, Mrs. Benoit. No, no. One of them's coming back. Oh my gosh. Here we are. Like that was smooth as silk. So by now what you should be able to do is define the origin and explain where it is. And what you also should be able to do is to know what makes it something proportional and non-proportional. We should know that it has to pass through the origin and it makes a straight line. And you should be able to solve this. The cost of a movie is $12 for 1 ticket, $24 for 2 tickets, $36 for 3 tickets. You should be able to use a graph those out, draw your line, and then determine if it's proportional or non-proportional. As always, if you have questions, you can ask me or Mrs. Benoit, or check your book, or rewatch this video. Thanks.